Hello. Hello. Give it 1 more minute for some more people to show up. Also, after figuring out a few of the, okay, I guess the microphone is working. It's just really low. There. years.
Recording in progress.
Hello. All right. We have some version of this being recorded for today or later, but I won't be able to hear from anyone online. How's everybody doing? Good. Excited for the long weekend. Gonna spend the whole weekend writing. Is why you're here for today, and you're looking forward to doing that. Cool. Good, because today is going to be it's going to be much more collaborative today than the things that we're going to be doing, especially for some of the exercises. So today is going to be a lot more about doing structure, particularly, I might have to write a lot of things very often. And we want to be like, a bit more methodical about the way we go about actually starting the writing process so that we can edit things a little bit faster, be able to share things a little bit sooner and get feedback. That's a lot of what the structure is that we're going to be talking about today. So again, so writing is still a skill, which also means you're going to need to practice some of these things to get more used to them, and then you'll have like better reflexes and your style will be a little faster. That's always very vital to your research success. I'd say like probably half the time you should spend writing, whatever it is. If it's jotting down notes for how your code works, they still want it to be able to understand, drafting out some examples, even the mathematics. You still should spend about half of your time writing, the other half the time you're coding. It's usually a good balance. So then here today, we want to figure out how to write, not by revising sentences or paragraphs, because we did that already in parts 1 and 2, but entire documents, until the point where we can start to think about, okay, these look right. Like I can almost visualize how the rest of this document is going to go according to the way that's been edited so far. But then what does this mean? Especially in terms of like look right in this case and easy to share and use. So in this case, we want to really outline, what is it going to be good to actually make it a totally good document such that it's very useful and easy to understand. Very much in the way, when you go to code up like a software library, you often think about all the functions you have to create, how they're going to align with each other, even how like the names for them, their inputs and their outputs. In some ways, you can even think about parts of doing like an outline in your writing should function this way. Like there should be at least somewhat logical outputs at the end of every section, for an example, that leads into the next section. Otherwise, these aren't building on each other. And you've got like a very sparse API library that doesn't seem like it's for one cohesive project. So we want to be able to explore some ways to like also do this in a nice way to keep our documents really clear so that when we can share them and get feedback, they're clear. And understand still how to organize and express texts to make our ideas really clear. So I'll review, we're going to be doing a little bit less of pitfalls today, and I'm very boldly hoping that today I'm going to be able to write an entire paper in the hour and 15 minutes we have left, and we'll start from scratch and just one project idea. We'll see how far we get. With still the main goal of like we write to have like very good papers. I often make the suggestion like go for things that you're sure will be like best paper awards and things we'll be really proud of to have other people read later. And I'm adding an extra goal onto this, general kindness, but also like work well with others. Because usually writing is a collaborative process. Not too many people ever write anything on their own. Like even people who write novels, they have editors that turn their kind of messy junk that was the good concepts into things other people understand. And they pay their editors a lot of money. to try and help them convert their, stuff into more cohesive documents and information that people enjoy. Okay, so this will be a bit of this for today. All right, so the mindset for today: how to succeed in research. For the moment, I'm going to just say literally, just avoid waste. Like the point of this really for the workshop today is you want to be able to write stuff. You also don't want to end up writing stuff you'll probably won't end up using. So how to identify and go through the writing process so you don't end up writing lots of things that don't end up going into the final version of the paper. So it's usually by this, I just say it's not really about maximizing your time and working 24/7. Really, it's just about making a good use of the time we've got. Like that. And then always, okay. It's also a little bit about working on your best ideas, the things that'll be, impactful that you want to work on. So any questions about those goals so far? Those are just sort of the mindset I'm going to use when we're thinking about the way we're going through the writing today.
We usually get some version that we write space, put it in another work space. This should get the news. How that's your.
So just kind of write on what comes natural for you and then reduce stuff later. So that's still true. And even for the outline we'll do today, you should write the document or whatever as if it's everything necessary to explain to get it to work. And then unfortunately, we live in a research community where now we have to cut everything down to 8 pages. And later we'll have to selectively remove things, be all right, what can we remove that still makes us follow what our original intentions were the best? And stuff that maybe the audience will know already. And we got to make sacrifices there when we make those choices. But even a lot of what I'm going to start with today is literally just write what comes pretty natural to you, and then slowly make passes on things that are kind of less natural. When you got to be really careful in your word choice to help make things clear. Yeah, does that make sense? When you're writing your thesis, you don't have to worry about any of the cutting down of words. That part's nice. However, a couple of the people that I know that I think are better writers, they actually say a good version of a paper is actually you write the entire thing, and then you do remove 50% of the stuff that wasn't absolutely necessary, and that's what makes a good paper in the end. Is now you have to painfully remove stuff that aren't absolutely most important towards the point. Thank you. Okay, so about writing quickly to achieve these things. So it's often about organization. So if you're going through the editing process, you can keep things organized for the entire time. This makes your life so much easier. It's so much easier to edit things. It's so much easier to share with other people. It's easier to see really quickly, am I going to end up being a little off track, or if I put things inside of this document structure that don't need to be there as well. So focus on that a lot. It's also a lot about a development process. So I'm going to be giving you a lot of tips that help me and a bunch of other people that I've worked with as well, go through editing quickly. And because I just have these processes, they end up eliminating a lot of the common pitfalls that you get stuck into. So it's a lot about doing this version of rapid prototyping. Just want to get down the main absolute ideas in an outline really quick. And then if it's useful, if this is one of our better ideas, then we can go into adding more detail later. Maybe after we get some feedback from some peers and they say, okay, that isn't actually a crazy idea. That's starting to make sense. And then let's work out some more details to make sure it really makes sense and will work. So a lot of this is about, I guess, a version called nonlinear writing, which means I don't start at the introduction sentence and then just try to write the entire paper from there without making any errors. That's usually extremely error prone, and you end up concluding things you don't need. And this is where instead you do iteration. Let's make a quick pass over what we want to do. Then go in, add a bit more detail. Then if it's organized well, talk about it, but you might be able to split sections. Other people can write the method section now that we've actually talked about the organization well enough. One person can do the related work section. And now it means if you can collaborate on this document, well, it's really well organized. And add some more details at the end. So this is nice in terms of keeping things organized, but it really supports collaboration. I'm guessing everyone in this room probably has at least one supervisor. They'll probably do some collaboration with you and some bit of the writing. So there'll always be some collaboration on any of your writing. almost no matter what. And a lot of this also helps avoid writer's block. So maybe sometimes that I've at least noticed for a lot of people is if you do this like non-linear, you start as introduction and be like, okay, I somehow need to put my entire paper down in 8 pages. You feel like there's now like 20 different constraints you need to satisfy before you even start writing, and it all has to be perfect. Immediately, this is like not even writer's block. This is like writer's cliff that you just can't get over right now, or writer's wall. So we're trying to avoid these things so you can feel much more natural to start writing. Okay. So any questions about writing quickly? All right, cool. So then part 3. So this is a little bit more themed towards writing a research paper, of course. So when we're writing, we're going to start with writing an outline in a minute, but we have to always consider like kind of like the things that kind of support our table, which is our research paper, which means that we're going to have some problem that we're focusing on, whatever it happens to be that we're trying to solve today. I don't know, maybe we're trying to turn the sun inside out or something like that. That's just today's problem we're going to write about. The obviously incredible method you must be using to be able to turn the sun inside out. You have to be able to describe that well so that it comes across clearly. Some evidence to show that, maybe you turned a smaller version of the sun inside out. Great, that's an awesome experiment. Congratulations. And then some novelties. Like, okay, no, this wasn't done already. This was something that we're actually contributing into the community. So these are the kind of main points for like the pillars that your research paper should stand on. You want to make sure that each one of these are really clear in the paper. So you should have parts on your outline that focus on each of them as well. And the part that people often find pretty tricky when you're doing writing is how detailed do you need to be. So this is where we're just going to kind of like go into some examples today. When you put something in your outline, it basically says like, fill this in for some information about reinforcement learning. Probably does not mean like copy and paste everything from the introduction to reinforcement learning book or the deep learning book and put that in the methods section. You're going to get like 2 paragraphs. So like, what is the context you should put in there and what should go in there? So often this is kind of tricky, but I think about the flow. Like, again, what will be absolutely necessary to put in the methods section so that anyone can actually understand what is absolutely necessary to put in the background section so someone can actually understand anything about your method. So you have to think, all right, your audience is probably going to be someone in this room, or at least like with the skills of someone in this room. So they know some mathematics, some machine learning, but maybe they don't know more specifics. So you have to explain some stuff related to like normalizing flows because they only know deep learning. They haven't used that before. And you're going to use those later. So usually your background section is still very specific for a research paper. And we'll get down to some of those details. Okay. So this is where this is becoming a little too prescribed in our research area for how often we just like follow this exact format, but I'll still start with this for now because many of the stuff I talk about are like good guidelines to keep you going on things. You're probably going to break a few of them when you have to, but try not to break too many of them because then you get lost. So like the intro is always just supposed to talk about the problem. What are you going to be trying to solve in this paper? Why does the reader actually care? And that's the message you need to get across. And then the related work section is, okay, what is the prior work? And almost the related work section, if you're writing well, is really most importantly about how is your thing different from prior work? This is like the related work section is a little bit maintaining the novelty for your method. That one pillar, you need to make sure that works well. Might as well mention it while you're talking about all the prior work and why your thing is different. And the background section is always just some fundamental mathematics that's absolutely necessary, but isn't actually part of your method. So to be honest, one of the nice ways to think about the background section and the method section is you want to make a really nice, clear delineation, like separate what is the old stuff that you're using, and then the method section was like, this is new stuff that you are actually doing that now you've set up to this point, no one else has done. So clearly make a section for that too. And then you can say like literally in terms of lines on the page or page count, this is all my new contribution. Even if they try to complain, okay, it wasn't perfectly novel. Schmidt-Hubert probably did this 10 years ago or something like that. But you can at least say you did something in addition here in terms of text. So making things super clear is very helpful. And then you have to have at least two parts, like your experiments. This is your evidence now to back up why your method is good. And your conclusion, which is really a summary of all the best parts of your paper. We did this. This is why it was great. You're welcome. Something like that in the conclusion. So like any questions about like kind of like the purpose now for each section of the paper? No, pretty clear so far. I mean, you should put future work and limitations. You can put it in the conclusion. Sometimes I feel it's not the best practice to put it in the conclusion. Like if you're talking about your method somewhere or in your experiments, the best place to talk about it is in your experiment section. Like we did this good. I was able to turn the sun inside out, but I accidentally tried it on Jupiter. It turned it right side in or something like that. And this is a future limitation. And that happened possibly because of these reasons. It's okay to put it down in the conclusion. That's kind of the like fallback option. But now you might be really disconnected with like the reasons why this future work is necessary. It'll be a little bit more disconnected. That's a bit of a style. Sometimes it depends on how complicated you want to mention your future work is. So if it's highly related to your method and literally like you can almost already see what the limitation is, then you can probably put it in the experiments. But if it's more like, okay, my method isn't going to work on stars that are bigger than X. Well, I could probably just put that in the conclusion. It's not specifically tied to the mathematics for the method or the experiments. Or you might have a different conclusion where it's more like, we didn't have time to run our experiments on this. That's a different type of issue in terms of limitations. Yeah. All right. Yes.
I once got a design reviewer telling that my conclusion wasn't a conclusion. I was merely restating it. The kernel truth is what they were saying. So how does the conclusion differ from just
So I guess this is sort of the difference between a conclusion and a discussion section. So you could instead call this like a discussion section at the end, or have a different thing after the experiments that says discussions, and then you'd really talk about like the details of why things didn't work or didn't. So it's a style bit there too, if you want to either include that directly in the experiment section, which often I find it more useful because then you can talk about the experiments and draw some actual discussion and some conclusions a little bit, like literally next to the experiments. And then but then the problem with that is then your conclusion then does become kind of small. You really just be like, here's a quick summary of the actual findings. I thought they were good. Maybe add some future work and limitations. So it's almost maybe, I mean, depending on the paper, that reviewer is like, that is a conclusion. Like literally your conclusion is always supposed to be like, this is the end, this is what we talked about. That's different than a discussion section that might want to try to add more for a broader outlook on the experiments that you've done.
I was asking, like, I was thinking that if we can still future work and limitation of the conclusion, because I feel if we don't really like have the results and we can conclude our work, we won't know what would be the future work and the limitation. Discussion, but I feel it still makes sense to have them under the conclusion.
Yeah, so that's where, if you're talking about future limitations, that's the conclusion. If you have a discussion section, it's very often better to keep that where you can actually talk about your method more there, not necessarily future work. This is, I would often like a discussion section should be like a broader view of the impact of your work. Maybe the best way to think about what's going to become.
I feel like most conclusions that I read also include like a restatement.
It's true. A few of these are becoming a little bit where it's like the paradigm in our research community lately, where everyone was like reviewing a paper and gives themselves like 26 minutes to actually read the paper. So you might as well restate everything 3 or 4 times throughout the paper to make sure they don't miss the point of the paper. Where I'm sure if you've got some reviews before, Usually the most common one is like, okay, I thought they were doing this, and it's actually not what you were trying to do in the paper at all. So it's okay to be repetitive, especially about the problem you're solving. Because that's like, you have to start with the problem. Like literally, what are we talking about here? And I would remind people of that in the conclusion, where if they think there's some mismatch when they get there, then if we've written everything well, then they've gotten lost and forgot what we were trying to do. So it's a trade-off. In that case, but I do like, I would on average, given who is the average reviewer and their level of busyness, I would do the version, the conclusion that reminds them of the main points of the paper. If I had more space in the paper, I would put other stuff that's in more detail. So this is more of a, remember your audience, remember in this case, probably your reviewers many of the times are people, and very fallible people, just like we all are. Okay. All right, so let's give one of these a try. So the first thing to always start with is making a pretty good outline. And the reason why this helps is we want to be able to carry these coherent so that we can see the overall structure. And this should contain really, really general outline type stuff, you know, for the most part. And then we can add more detail to this over time. Okay, so this will be our outline for today. So we're going to start with stuff. All right, so we need an introduction. Is everyone okay with the problem? I was going to switch this to being able to identify the number of planets in the solar system. Is that okay, Topper? We'll still use machine learning for this, but as long as it's not too far outside of people. Okay, so now the problem is
We use astrology.
I don't know astrology as well. Sorry, my topics are limited to machine learning and swimming.
Machine learning is like astrology.
So we want to start out with, so this is the first part, we'll just do like the intro. So the introduction should usually have at least 3 or 4 parts in it. Like the first part is, okay, so what is the problem? So it's not just like how many planets are out there. That's a nice kind of overall example, but we want to use this information. So it's literally like, how can we identify the number of planets that are out there so we know how many habitable planets that are possible? Fun experiment. My apologies. Something like this, with slightly better spelling. So the introduction is usually kind of split into 3 parts. So like, what is the problem? Okay, the next part here where I feel like I've left some input. Why is it hard to be able to do this? Why isn't someone already done this already? Seems simple, right? Just like count the number of planets.
So is this a paragraph or more like a sentence?
So this is basically, so which part of the intro? Basically, these are going to be the topic sentences, more or less, for each paragraph. No more detail. Don't really even need to put a sentence here.
Entire paragraph. I'm just trying to understand vision, so like for this. How does this become a paragraph?
Well, you'll need to add some additional parts to this for sure. So how do you identify how many planets are out there? So you want to introduce why this is an important problem. So we want
So it's really, like really, you could say like the paragraph is about what is this important problem.
yes. So it's sort of like you need to feel comfortable that you've satisfied this criteria after you've written the paragraph. So like, how can we identify why this is an important problem? So you can add some stuff like, well, I want to get the number out there. Maybe they'll be able to help me convince everyone else, all the people on the planet, that we should worry about the climate. And some other things that are also fun. And make good friends. I might also get to know about other planets, spread my horizons. There's a whole bunch of interesting reasons for this. So you talk about like what the problem is and why it's important. Is usually the first paragraph.
So like, should we feel like why and like how?
Mhm. All right. All right. We want to identify how many habitable planets are out there. So this is sort of okay. First paragraph is convince people why they should read anything beyond this first paragraph. And the next part is okay. So the second part of this is always, or at least as a good rule of thumb, is to convince people why you're really smart, partly. But like, so why is this a hard problem? I know anyone hasn't done this before, and this doesn't have to be perfectly accurate. We're not going to submit this paper by the end of today. Wait, no, why is this a challenge? How come we can't identify all the planets and just count them really easily? I guess you can just do this. So like, what are the limitations of current methods to count all the planets? There are actually some really complex limitations. If you're into this kind of stuff, one of them is just literally like planets are different sizes. Most of our machine learning models have been like tuned to be like the object of importance is right in the middle, takes up most of the image. It's such a dumb reason for why they don't work really well, but now they can't be used to count things very easily. Not typically. Okay. Sure, question. Okay.
When you say out there, is there any scope to be,
Okay. That's a good question. So this is where you need to sort of actually like point C here, I guess is actually where I like to get it. Because it's going to be often like, let's propose a somewhat conceptual solution. So like if this is hard, what are like the two or three things that we need to be able to answer this question after I made it sound like it's a really hard thing to do? So you should define what is there. So even if you can just say something along the lines of like, I had a conceptual solution use ML to count all in the way, which I think is 2 words, so I don't really remember that.
so you mean on the universe level?
Yeah, so not even like inside of the Oort cloud or anything like that. Looks like Grammarly's not doing its best job today. But maybe if I capitalize things and it doesn't think I'm talking about a candy bar, it'll do a better job. And so I haven't provided much detail here yet because, you know, the concepts are a little outside of what we would normally talk about. So I did email everybody like the slides beforehand, so you can get to see this document we're editing now if you want to add more comments or copy this for later. So inside of the slides for today, you should still be able to click on this outline link and see what we're doing if you have any questions. Okay. All right, sounds good, right? There's not much detail for this yet, but we're just making the outline. Like obviously we need to people in the beginning of this. This is a big problem. Then we talked about why it's a hard problem, why it's worth putting all of our research effort into this. And we already know why it'll still be useful in the outcome. And then we need to provide just some conceptual solution. I haven't talked about any mathematics yet. Just if I can solve that problem, like literally, we can solve the it's kind of like the pixel proportion problem for ML. This will be easier, literally. And this is an actual research problem. So if we can solve this, then we can actually learn how to count planets better, and really anything else that ends up being an odd version of it. So this is already, it's just a conceptual solution too. It basically means like literally, we're not very good at counting things when the proportion of their pixels inside of the image is really small. Our models don't tend to pick these out as easily as having like the cat's face takes up 90% of the image. Is it a cat or a dog? We've overfit that quite a bit. Great. All right, so the next paragraph, very often we get into this. So give me some more detail on how you're actually going to solve this. What is some math method that ends up being able to weight pixels more evenly than your average machine learning model, like something that should be connected much more later to what you're going to introduce to the method section. So in this case, I guess I've got a bit of a hint since I know one of them is also on the call right now.
I'm a bit confused. Shouldn't CI go under BI? Under BME?
So,
Okay, we're
so
just,
C is supposed to be starting to be like, this is how I'd go about solving the problem.
yeah,
So I would say, like, what are the limitations up here is more so ML models don't like sparse pixel information. And then I can connect this to like the proportion problem at the end and how to deal with this particular issue.
okay.
So then we need to be able to propose some particular method that needs to be able to do this. I'm gonna pull one sort of out of my hat that I'm not wearing right now, but propose some new convolutional network that detects sparse information better. So like this is just still like an example. Now this sounds about right? Obviously I'm making most of this up right now, but at least it sounds correct. And at least the point I'm trying to get across right now is like you have to keep questions. Like I think you could probably start to write a few more sentences for what is the first point, right? And then the second, you can think about a few things like almost anyone in the room, so we can collaboratively edit it. That's the point too. Like one of the a current machine learning. So I might know that one a bit better. So maybe I'll take writing that paragraph. But then you can provide some conceptual solutions, like what are just machine learning models where you've got issues between detecting sparse things versus dense things. And then your last paragraph is usually more of like just your claims. This one is hard to be specific here without knowing what the experiments are going to be later in the paper, because you can't claim stuff without some kind of evidence. So here it'll probably be, I developed the thing that ends up counting the most accurate number of planets that are actually in the Milky Way, according to some held out data sets. Not entirely sure what those data sets are. Yes. So not exactly. So you can make this trade-off when you're writing your own paper. But the reason that I like to do this, and it can work really well, is it also separates out the knowledge that the reader needs to know. It's just because like C is just providing like a really high level conceptual version of the problem. Like we need to figure out how to handle sparse problems better. And I can talk about the difference between sparse data and dense data without even talking about any math yet. So it's kind of like even people that aren't in the machine learning community that understand A, B, C, and hopefully E, and then D is going to get a bit technical for them. So I want to put the technical parts in D, where all of us might go more towards D. Like I want to know the technical things that they're adding on to solve it. But if you organize it this way, it's more towards the audience I'm going to pitch this to. And just in case my reviewer or reader doesn't happen to know my technical area really well, I want them to understand the conceptual problem, its difficulty, and how we could go about solving it without even having to know anything about my research. And that's where, and this kind of leads later to, will be a related work. Background, wow. And methods section, where, this is going to kind of be a little bit more full. Okay, sorry, autocomplete is going a little crazy this morning. So kind of part C. Sorry, part C leans more towards the background. We're still giving like general knowledge that still most people should know. And you want to find this nice separation. Again, in part D, we'll end up feeding into the method section instead. We're like, whatever you promised here that should be good, you better introduce some good mathematics and intuition in part D, otherwise it really makes sense in more. So it's part of the things we talked about in the last part of the writing workshop about doing parallelism. So I'm kind of literally each one of these and a section of the paper, like the first paragraph. Really becoming a lot about the related work and why it's hard. People have been trying to solve this for decades. Here are all the papers that try different things. Here's the method we're going to use. It's different than those. So you repeatedly want to also ensure they understand the novelty of what you're doing.
So one feedback I often get is like that you want to understand the main things about the paper up front. And so one thing I wonder about it, it seems like one is like interesting about the paper isn't coming until paragraph D. And everything A, B, and C are kind of like, you know, not really, in some sense, like what a reviewer to be like, you're not getting to the main point. Do you feel like we've already gotten to the main point? Is this a problem or?
So by the main point, do you mean like the main?
You know, like
It's not the main contribution.
And so we're talking about how we have a paragraphs now, and really, we're just talking about it in a very general way. We're not really saying like what our contribution is. So
And we're not like getting into the math in the first sentence of the introduction.
well, it's not about the math, it's also like not even really. Like, some people are trying to and machine learning techniques. And what maybe graphs do, for example.
So you've got some flexibility on how you can do the first paragraph. So if you want to say, I want to be able to get to some point where, like, you know, maybe they want in the first 3 sentences what is going to be the overall main content or conclusion from the paper, which, to be honest, is not a great way to write something, because then, like, how do you even introduce this if you haven't talked about what you're going to do?
I'm advocating for it. I'm more interested in, like, I feel like I get this kind of feedback sometimes. See what you think about this in terms of, you know.
So I guess I'm gonna put on my like more brutal professor like hat at the moment and be like, I guess we often can get that comment from actual reviewers, and they might say like it doesn't come across early. It's very often more that it doesn't come across like well in the paper. So like I feel like the use of the word early is actually not very helpful. And if we do a better job of like really clearly getting to what the actual, like just overall clearly explaining what is being done in the paper, this ends up solving this problem 95% of the time. And then you could move a few sentences up into the introduction paragraph that starts to describe that stuff later. So you could say, you know, we want to be able to identify all the habitable planets out there. Maybe getting to know aliens isn't a good example, but you know, we want to be able to understand if there are other planets we should actually send like additional spaceships to. But we need to figure out this machine learning problem beforehand, because this is a lot of sparse data. So we're already starting to give a hint towards like the problem we're going to face applying machine learning methods. So I would do that for now. And I would only bend to that concern if most of the reviewers said that for the paper. If one reviewer ever said something, fine, I don't care. It's not a consensus among either like the AC or something like that. That's going to say you need to rewrite the entire paragraph, like paper, just to make this one reviewer happy. I would say you need to like kind of also take a bit of ownership for like, we're going to write things. We should know even better than our reviewers how to explain these concepts and make sure that people understand them.
I guess I'm thinking that not necessarily from the perspective of reviewers, but like especially when I talk to people that come from like outside of like math and machine learning or something, I feel like the tendency like more scientifically minded is just kind of like proposals and then like build up their argument from there. Whereas like now they need to kind of walk along the whole journey.
Yeah. So like what for that example, I would specifically say like your point, like point C. If it's someone from outside of your area that's not going to understand or possibly care about anything that you do, They need some conceptual thing for like, why are you going about what you're doing? Why are you introducing this? Where are we gonna go? Because like, they really need like, basically in these 3 paragraphs, I think you need to solve what you're talking about. And then in the paragraph D, it's more for the people in this room. I think, okay, I actually want to know how to solve this, because I'm gonna build this thing. And I want to know how related it is to this stuff I'm doing. So it's imperfect. It might not be in the first sentence or two. You can make this paragraph shorter, it takes a little longer to get into the details. It depends often. So maybe that's sort of a good note for now. Or maybe you can add some notes. The proportion of each of these paragraphs often depends on how novel is the idea and problem you're doing. So like this is not a very novel problem. And it's a solar system. People have been counting these for millennia. So I can probably just add like 2 sentences about this. Probably talk about why it's hard. Probably spend a lot more time trying to see and get into the details for what's going on. Yeah. And I certainly have some paragraphs or some papers like that.
What's your mistake again to like
So
how many sentences we're gonna have for each one?
you see that. So if
You don't have access to it.
they like getting denied access.
It says requested access or access to an idea.
Okay, so
I think you need to make it public. Wait,
only people with the link. At least everybody at Mila can comment. Does that at least allow most people to be able to see this now?
yes.
Wait, done. Maybe it works now.
That works.
Okay, cool. Thank you. So if the problem is very new, you will have to spend more time on paragraph 1. If problem is old, spend more time on probably C. So like in this case, like if someone's, forgive me, I'm more of a reinforcement like person. If someone's problem statement is like, we want to do reinforcement like which is like every other paper basically. Learning. Okay, I think people understand that intuition. I don't need to convince them that this is an important topic. I do need to convince my important conceptual solution is going to be good, but there's already 1,000 other ones, and then it's going to be equally important. So you're going to end up using a lot more of your attention on these 2. Okay. Good for now for introductions. We'll come back. We're going to make a few more passes on this when we have time. So the next part is, okay, we're going to have some related work section. So first, probably even like some just stuff on counting planets.
You should click comment so that we
Oh, sorry. No problem. Stuff on counting planets too. What a planet is. I don't know if you remember, like Pluto was demoted not too long ago. So we've got different definitions for planets that are changing. But then we're going to have a couple of different things. Okay, so we talked about an introduction, some solution here, and this is going to have something to do with dealing with sparse data. So we're going to have some related work on sparse data. Definitely, and then ML methods for interesting convolutions. Like we need to identify what are the larger, somewhat large bodies of work that we're going to end up needing to relate to, mostly because we're going to end up building on any of these or comparing to them in the paper. So usually, like very often, your related work section is going to kind of write itself because you're going to know what you're going to compare to later in your experiments. So when you get down to the experiment section, you're probably going to have at least some prior work that you're going to compare to. Sparsy 9, something like that. There's probably a name for some particular ML method that might do something like this. So then that means you're going to not only have to explain this method, you're going to need to explain the group of work that led to this method. And then always, like extremely important, end of each paragraph, explain why your work is different. So that's where I mean, like if I talk about this method, maybe there's some prior work that does some type of convolutional method that happens to not be so sensitive to where the number of pixels are that are in the image. So you've just talked about like everything that can really be related to what your method is, then at least put a sentence at the end, be like, but I use, I don't know, like Fermat's last theorem in this case, and it seems to be better for showing and handling sparse data. So you can at least say like part of the method is novel compared to all the prior work. This is again like ensuring novelty as you're introducing other work.
Are you related work session? I guess, do you think that it's possible? Like this, but not like, can you say like in advance what you should talk about if we don't care, but that's already there? Like, for example, if like most related work is already very extensive, like maybe you don't have space or like I any, or maybe it's also I guess like is how would you like write related? You should start with say outline like this or do we top down or bottom?
So it kind of depends. It's going to depend again on like, yeah, how I would have said like just how novel the problem is. So I know how much work is related to it. But if you're doing, I guess if we're going to the example just for a second for like deep reinforcement learning methods, you're probably going to have different sections on like data efficiency for reinforcement learning, better representations for reinforcement learning, and then most related methods, which are probably using something very similar to what you're doing. So in this case, where I would say like making two, this is why we kind of do different passes on this to understand how important these parts are. So I make the outline in the beginning just to understand I'm not really missing anything from the coherent document. I'm not leaving things out. Yeah, some of these paragraphs, you know, maybe this one ends up being much larger than the first two, whether or not it's because I have to leave space or there's a lot of work in this area. So I guess what's missing here in part of the outline is not each one of these paragraphs is going to be the same size. They're going to be probably vastly different depending on how much work has been done in the area. But if you're writing some paper towards things, you know, like the one cheat code you can usually apply here. So if we're talking about Sparsy 9, the paper that does this probably has its own related work section. You're most likely going to have to cite a large amount of that stuff from the related work section and see how they organized it. Maybe you'll change it if you're using a very different method or background than Sparsy 9, but that depends. So often you're not going to totally write your related work section completely from scratch. You'll have some paper that you're building on.
So how do you think about the balance here? Because it seems like there's like repetition potentially of something that's Sparsy 9 in the related work section, and then you're mentioning it again as a baseline. So like how do you balance that without repeating content?
So it is sometimes a bit of a trade-off. I mean, if it's absolutely related work, so it has to be in the related work section. If you introduce it somewhere else later in the paper, it'll be very confusing.
Would you move the related work section up like later so that it comes right before the experiment section?
See, I find that usually ends up making a paper slightly more confusing to read. Like if I go through this, I don't, like my best way to understand if something is novel is like, okay, I need to put it in a frame of reference for some other paper I know to see how they're building on it. If you don't talk about any of that till the end of the paper, I'm going to question the novelty of the paper the entire time I'm reading it, and I won't know how to understand like what is literally like the step in novelty that was taken beyond most related work. So again, most of the time I put the related work section earlier, Partly because it's also a nice trick where I can start to introduce stuff that'll be in the background, sort of, and those concepts. In that way, and they'll kind of connect a little bit. So the real problem is if you put the related work later, you're also going to end up kind of explaining a lot more in your background section that you could have put in the related work section. It's conceptual stuff. You can't put math in the related work section, but you can start to talk about, I guess, things on how to actually identify a planet. So I could have already talked about the metrics for this, and then just have a sentence or two in the background section on what the math is for defining it. If I don't do it that way, I need to have a large paragraph explaining for what the metrics are, why they're popular, this is the most popular one, and then give the math for it. So it ends up consuming more space, for sure. So that's part of the choice there. I think you had like the first part of the question.
Like I imagine that like you're gonna say like, okay, we're person 9, and then you're gonna talk about it for a while as kind of like the baseline section of your experiment. So, or like you maybe also talk about person 9 in section 2. So I'm just trying to figure out how to balance that and like how much you need like just reset things.
Yeah, I guess I would normally do what I'm going to call a little bit of web weaving. So I would introduce Farsi 9 here. And then I would also say, since you're already talking about the fact that your method is novel, and maybe someone will think this is highly related to your work and wants to know that it's better, this is going to be a little too latex-y, but like auto ref, spare section, experiments, prior methods. Like the fact that I'm going to say it here ahead of time, we will be comparing to this in the experiment section. We show that we're better than it, is where I would start to introduce this. So I wouldn't leave this completely separate and introduce this prior work and why it's important to compare to later. Does that make sense? It's going to make the related work section.
That just make the problem worse because now you're talking about the experiment. Now you're talking about these before these later.
I guess I'm not going to talk about the experiments in enough detail that I'll need to know any of the information about the method or how the experiments are run.
Right.
Just that if maybe our novelty isn't that our method is much different, but that it performs better, then we can say like, here we need to back up for why our method is different. We can just say like, and see our experiments at the end of the paper referencing this section that show that we just get much better performance. And that's one way to say your method is novel. And then you'll most likely just be able to remove having to explain this at all in this part of the paper. So I guess right through. So it's basically I've taken that portion and moved it into the related work section. I don't need to explain it twice. All right. Yeah, does that make sense? Depending on your papers and things too, if you are writing a paper where there is a lot of work in that area, it's helpful to have this like last paragraph, like what is the most related work? Or it really is a version of your experiments, where people would sometimes call them baselines, but I really don't want to encourage people to use the term baselines for what is prior work. A baseline is a slightly different concept. Move this prior work chunk into the related work section, where you can now talk about how your stuff is related to other things. Question.
I feel like I've seen related works as put in the appendix. What's every little word? But also, why would people do that?
I mean, putting it in the appendix is a crime. You could potentially reject a paper if they're not actually citing related work as a way to make it look like your method is novel while ignoring a bunch of things. But there are versions of papers where they might do experiments, results, and then put prior work.
You argue that the background section sometimes could be redundant with the related work section, where it's like the background section probably already includes the most related work. And then the related work section is more like a bring your perspective, that's like looking at a little bit necessary to understand your but we're just like trying to cite people and give a greater context.
I mean, that is often the point of the related work section. And these days, there's so many papers that often you'll talk about interesting convolutions, and then you'll have your references will be like 12, 45, 67, 23, and like a whole bunch of stuff. And you'll group all of these, 5, something like that, into one thing. These are all the things that happen to use this type of convolution in 5 different ways. That's fine. You group them all together. You're talking about stuff at a high level. The background section is, I would say, more about introducing some of the fundamental math framework to start to talk about how your method works. So, for me, I guess we're talking about this. We're going to have to explain, maybe we'll do some stuff for deep learning, probably not, since we've already talked about a paragraph for that here. But we need to start to have an idea of what our method is. So let's make up a bit of a method for the moment now. So we're gonna need some kind of like special sparsifying thing. Needs a special sparse network thing. Based. Okay, so basically we know we're gonna have to talk about basically literally how to compute if sparse. You're going to need some measurement of sparsity, something that can actually compute something that's sparse. And then you're probably going to, in the end, somewhere in here, that your method can optimize some objectives that does include things in the concepts that are sparse. So it's kind of like in the method section, you should start to introduce some of the, in the background section, start to introduce some of the math. Usually, again, this was related to paragraph C, so like a high level version of the objective function you want to solve. So in like a machine learning paper, it'll be like, we probably want to minimize some classification loss for computer vision, or in this case, a count loss for being able to count the number of planets in the universe. If it's reinforcement learning, if I have to get to some point, we're going to talk about, like optimizing your sum of rewards, either finite or infinity, something like that. And it's sort of like you've gotten to this point, and now you need like the ugly details. It's kind of that version. If you think about like probability distributions, like I could write, I want to do like log probability maximization, but you actually are going to end up using like a Gaussian distribution. That'll be in your method section, how you do your particular form for the Gaussian distribution. Whether or not your variances are fixed or you're using a full covariance network for some reason, then you'd get into those details there. But your general version of the objective should be in in the background section. Because you're going to need really just background math so that people can understand what's going to go on in the method section. So if we're doing some of this, get a bit more feedback from the group too, since I'm having fun making up my own like methods here as I'm talking about counting planets. So we got something that's sparse. What else should we include in the background section? What do you think will be needed for the method section? Any ideas? So we're at least going to need to define so we do at least need that function that says like this is a planet or not. So we can include that in our objective function in there. We kind of only talked briefly stuff on counting planets, but not the particular mathematical form we'll use in this particular problem. We need to do this so we can actually have a good conversation about how accurate this model is going to be and how useful this particular function for counting the number of planets is. And then we're going to try and approximate this somehow using machine learned models. So you're probably some above math. Hopefully that makes some sense. Most likely this is like functional form something as a planet. Like it's going to be a regression problem, most likely, or you could convert it. Let's just say it's going to be a regression problem. So we might pick a particular class of machine learning based methods that's going to be better at doing regression instead of classification. and we're going to build on those and introduce them. So we might at least, you could introduce things like we're going to use mean squared error as a loss to be able to match this, train our data. Our x's are going to be images. Our y's are going to be numbers between 0 and infinity, which is really large range. That's what we're stuck with for now. So you're going to start to like shape up. This is what the problem looks like. It's got these conditions in the framework for it. Okay. So any questions about the background? So often you can tell it's sort of like a good catch for some of these. So like if you can go through the methods section and there's no math introduced in the methods section that depends on needing other math, then you're okay. But basically, if you talk about some mathematical concept in your method and you haven't introduced it, go back and introduce that in the background section. So this is often where it's very helpful to probably get, if you're not like super experienced, get some feedback from others, and they'll be like, okay, I didn't understand the math here for some reason. You know, use not convolutional for people like this means, okay, we never talked about how to actually compute a covariance in this or the mathematical framework in the background section. So you at least have to reference something like that if you didn't do it already. But instead, I would say you should introduce a sentence in the background section saying, we're going to end up using a covariance like matrix, like the full covariance matrix, instead of just a diagonal one for this reason, and cite some other work for why, or like what the difference is between a covariance and diagonal matrix. So if you end up introducing stuff in the method section, go back, even have a little checklist. All right, was this concept explained somewhere in the background section, or was it introduced enough in the related work section? Then you're okay. So it's almost, you might go and write some of the method section and then go back and write the method section, depending on how skilled you are in that particular topic. Okay. Here's my one more pun for the day. We will use astronomically network stuff in order to be able to train this model. And things related to be able to do some additional training. So this is what our method is going to be made up of. All right, so we've got to be able to understand something about how to compute some sparsity, which we haven't talked about in the background section, so that's a problem. We're going to train on some special sparse network things. This is kind of the stuff that we're inventing. We're going to train this using an extremely deep network that might run something sparse. And for some reason, we're going to estimate the full covariance for this, probably because we have a lot of uncertainty about how well we're actually measuring and predicting the actual values and count for the things that are in like the image that we see. So this means that from here, we're probably at least going to need to go back. Oh no, I guess we already talked about how to compute if something is sparse. So this seems like this might actually make sense, right? So if I ask someone, like, okay, if you write that background math on computing something is sparse, probably it's broken up into coherent chunks. We can start to see some of the arguments. And start to define whether it's a planet. Does anyone in here do any research that's related to astronomical phenomena? No? Okay, so I'll pick someone at random. You can do figure out something at the planet. You can take that chunk and then define some function or something down here, be able to use it in their logs for why it's better. And someone else will take network stuff. It seems like half the people at Mila could probably explain this network stuff, so we're good there. But we probably might need someone more specifically to cover, all right, we're making an odd convolutional neural network that's going to have to do this and learn it well. So the method section is going to most likely be more challenging to write. So this is where I'm saying it's part of this is now we've broken up some of the concepts in a nice way so that people should be able to take chunks of these and edit some of them. And you can give this to somebody and say like, okay, these are all the reasons why I wanted to do this. This is some of the related work so far. Maybe they'll add a few more comments of related work you should include. And maybe something they don't understand about the method section. But this is like the skeleton for what we're going to write in part of the paper so far.
I have a question about, so what do you think of writes done in the math section? Have like, a lot of math concepts, and then later on, you have to use them to reader has to go back. Talking about versus like, right, when you.
So there's two thoughts. One is, we would still want to be careful that if we're including stuff in the method section that's not like novel stuff we're introducing, it can start to confuse the reader about now which parts that you're doing are novel or not, which means now they're going to start to have doubts about your whole method section being novel or not, which is, I don't know, at least for me, one of my largest fears, especially when writing a paper. So that's just like the bit of information to take away from that part. So what I would normally do instead is, okay, how to compute if something is sparse, then I would say, we implement 3.a using da da da. So they can like click, like make a lot of references in your paper using autoref. So they can click on that, it'll go right back to that section that explains what this thing is that now you're trying to make an implementation for. And I end up doing this quite a bit in my papers. Sometimes you can reference actual equations too to say they're working there. But really, maybe in practice, my answer to your question is, yeah, I use autoref in my paper about 30 times to make sure you can jump between the related work section to the experiment section and back. If people want to understand whether or not, like, where does sparse 9 come from? Okay, here's a link to how you can go find the explanation in the related work section, where the link is to it, and the reference for the paper. Becomes a lot of auto-refing ends up happening, but then you can jump between sections. There's a question? Mm-hmm. Yes, well, I guess there are like examples for survey papers. So those aren't going to have an experiment section as much. They're not really going to have a method section, but technically, most better survey papers will have like some like classification of papers into different groups, and they'll explain in a methods like section that like we group them together this way because they all fit under this like framework or mathematical expression that now kind of makes a nice separation between the prior works. So they'll still be often a lot of the template still fits pretty well. The proportion of how you use these things is going to change a lot. So a survey paper is going to be 90% like introduction, well, related work and background, and a little bit on the method section for how to group these together. So if you just want to focus on like a subset of particular methods, this paper helps everyone focus on understanding the relations between the huge amount of papers that have happened. So that would be like one. So in that case, you might not necessarily have a related work section because your whole paper is a survey paper. So you're probably not going to have a related work. You'll have, like, I mean, I guess if you're doing something like this, you'd have a whole section, if it was a survey paper, just on like ways to define on what a planet is, and maybe even the history of it. That'd be a good survey paper. And then you'll have some non-machine learning, well, some non-deep learning based methods for originally how people are trying to analyze these things. Maybe they were also using like radio frequency based sensors instead of image based sensors. So I'll have to have a few pages on that. So it becomes something quite different after a little while, but it's really the proportions change. Most papers will always need like some amount of each of these components. So you can still build that table of like, what is the problem? A survey paper, the problem is, my gosh, there are just way too many papers in this area. Where do we start? And then your novelty is, okay, I'm helping this community be able to understand the grouping of papers so they can navigate them easier, because otherwise there's a giant blob of hundreds of papers. The method you're going to use, yeah, maybe develop some framework to delineate them better. And yeah, your experiments or evidence are saying like, okay, see, now you can all sort through these papers easier. And you can mentally see that. And then maybe there are some other papers that are more like data sets. Yeah, do you have an example?
Yeah, but we put the reading documents. We're just putting out that later.
True. Yeah. Okay, so for something like that, where you're not, basically part of the challenge for that one is the experiments you're going to have at the end of the paper, there's kind of no prior work. You're not showing that you identify ray interference better than somebody else, but it's a property you're going to start to have. So your experiments here at the end are not going to be as much quantitative analysis of how you compare to other things, but qualitative, saying like there's some correlation between this ray interference and how well things end up optimizing. So you're going to have a different bit of related work where you're probably not going to have most related work anymore. Not at all, really. You're probably going to have a small paragraph here. If I remember the paper for a bit, they were borrowing some statistic methods from physics that had to compute like ray interference and some things like that. So they needed to have a related work section on like things related to ray interference and where it's been used elsewhere. Just to say, I didn't pull this tool of ray interference out of my backpack that no one's ever seen before and tried to apply it to this and said, hey, look, it does something. You want to give like some credibility to this ray interference analysis tool and say like, we really should apply this to deep networks. The overall optimization process and the complexity of it kind of fits into the other types of things this has been used on. So it's I would say the first intro and related work is going to stay similar. The background, you're going to now have to explain ray interference quite in depth since it's something from outside of our normal community. But the method is going to be more of we want to understand how optimization works, because you're not proposing a method. So you might change the names for some of these sections. It's kind of like understanding using experiment section will instead be qualitative analysis, just to see whether or not we've learned anything from using this tool. So there will be a few changes, but it doesn't change a lot. And this is still what I'd say. If you still mostly want to follow this guideline, and then you'll figure out if you're doing slightly different paper, you're doing some of the sections, so you end up having to make the background and method section kind of combined now, because you're talking about ray interference. So you're not going to be just talking about RL or deep learning. Something far more novel to the community. You are going to have a larger experiment section, a better conclusion, because people may or may not care at all about your analysis of using ray interference. You do a good job of convincing them that this unknown tool to them is good and that they should also use it. So it's kind of like, if you're writing a typical paper, well, where you're just doing like analysis where something is more data efficient, you can follow the template really well. All of your novelty comes from how good your experiments are at the end. If you're introducing a new method or bringing in a new tool, you have to spend a lot more time in the introduction convincing people that ray interference or whatever your new method is going to be useful and is going to help with some conceptual issues that are in our community. And then you'll have to explain the methods in much more detail. So you'll end up quite changing the amount of effort you put into different sections than normal. Does that help? Great. No problem. So other question, any other questions? We're good with my somewhat made up method section for now, right?
So,
We're deep learning people. None of our theory actually makes sense. We don't use linear models anymore. Yeah, I don't usually start with that in the beginning of my papers. I mean, even a method section, sparsifying something needs some special network thing. I would say first, intuition about a math method, and then a theorem. Sparsity times theorem, something like that. So if you're going to do a lot of theory in your paper, and I know I was joking a little bit about the fact that we all do deep neural networks so often, our theory that somewhat works in linear models doesn't actually transfer to deep models. So do provide some intuition about why you're leading your path for you to go towards this theorem that you're going to produce, so they understand. Oh, okay, I understand how this is useful, and if I want to use this later, how I can apply this to other things that are similar. Because if you go through writing a theorem, hopefully it's not just useful for your paper as well. Most theorems that are more broadly applicable are more useful. Okay, so then let's say we're actually running some experiments. So we've got sparsity 9, the prior work method that does well. The part where there are different ways to organize the experiment section. Again, if we're thinking about applying this tool, we want to make everything nice and coherent and easy to edit. So how can we break up the experiment section so that it's still pretty easy to understand and edit? So the part is always good to start with, just like explain your claims. Like literally what should be at the beginning of an experiment section are, you've got some claims that you made up as the last paragraph in the last paragraph in the introduction. Explain, like, these are the things that we're going to analyze experimentally now using our results. That's not just, and we present results. That's not a good of an argument to say, okay, we're going to analyze how well this method is going to do and understanding how well it can actually estimate like a, I don't know, like a spherical celestial body somewhere up in space. So we're going to do this qualitative analysis to make sure it can actually draw a nice circle or something like that around many actual bodies, just so we know it does the thing we said it should do. It'll find all of these sparse little circles in the image. And that's even just like our first example. Now we're giving the reader confidence that it's doing the thing we said it was going to do. Because if we just jump to saying, oh, and we have lots of results, you know, there's still a lot of convoluted information in there. And you have to rely on just like confidence of all the results working. So you might as well like claim 1, we can find planets. Cool, just show some evidence for that. And then you can probably come up with a nice specific experiment to do that. 2, we can count them. Boy, this is getting slow. And what should our third claim be? What would you like to know about this particular model to make you feel confident that it's doing its job well? Especially if you wanted to use this. Maybe we want to point it at a different universe, not the Milky Way. Any ideas? Maybe I'll go over some of the like general rules of thumb.
Anyone want to do something about applicability of comments?
Sure. So not just count them 3. There's not a lot of data for that one either, so it's going to be really hard to train habitable planet people. So these give you some information. So if you complete all these experiments, I feel more, comfortable that your model can actually find some planets. So you're not missing a lot of stuff in the data in some way, that it can actually count them. So give me a bunch of data saying it's matching the actual data well, and it's predicting things well. And then you have some other identifiable planets. So usually I like to put this as part 1 is some qualitative metric to say your model is intuition. So this is kind of like if I promise that I'm doing this in this case, and I'm supposed to be able to have a model that can identify things like sparse, give them some evidence in the first step that says if it can't identify sparse data in some way and go through it. Doesn't have to, don't compare it to anything else. Just say it does this thing. Because you usually make some kind of intuition plan, whether or not it's Like it'll learn from more sparse data, but it learns from more sparse data if it has like a better representation. So show them some evidence and yourself as well that there's some evidence that it's learning a better representation before even going to say, and this representation now makes it work better. And that's usually what part 2 is. And that's
That's like usually the opposite order that you see it in the experiment section. It's usually like quantitative analysis and qualitative analysis.
yeah, but that's weird, isn't it? Like if I'm looking at like programming something and I want to follow like the breadcrumbs of information that give me confidence in whether or not I should now expand on applying this to a huge data set and run big experiments. Usually I would say beforehand, no, I knew what I was doing and it had these properties that we would expect would help. And therefore, now if I apply it here, it ends up working well. Not the other way around is less clear, I often find. Where if it's like I apply this method to a whole bunch of different experiments, it works well. And now we try to go in and look at why it worked well. You know, it at least sounds a little bit less scientific. Like, I tried a whole bunch of different things. I accidentally stumbled on this thing that kind of worked. Let's as a group try and figure out why this works. And I don't really claim that I went through some intuition or effort to understand beforehand and look for a particular property. That makes sense?
I have you as like saying it works, and then you're saying indeed it works for the reason that I said it did.
Yes.
Right. Whereas, like, now you're kind of going, like it works like I said, but like you're kind of if it just works.
And it might be related to this property that we're doing like an ad hoc analysis 2 days before the deadline. Yeah. So it's you're trying to build confidence in like the reviewers as they go through the paper a bit. And I guess there's this really nice their paper I can share after this, but it's actually how like the Wright brothers went together assembling the first plane. So there was a bunch of people that worked and were getting huge grants from the government to be able to assemble different types of planes. And they were really doing like the random search type method. They're just like hire a bunch of students for the most part, have them modify the planes in different ways that match birds, whatever. And they were all hoping to eventually like a flying thing would just like pop out at some point. And the Wright brothers instead went, okay, we have this thing that's supposed to fly, which means it needs to produce as much upward force to carry the weight. So let's analyze what we can do to construct something that'll produce enough lift in order to actually carry the weight of one person. And then just did that for a while, and that was great. They could do that. Then it couldn't steer. They would like fly and then veer off and crash into the ground pretty quickly. It's like, okay, now we need some control over this thing so it doesn't go crash and stuff. And they could methodically go ahead. All right, now we can design a system with the intuition. Like we need this type of control method. Here we can show it gives us better flight and control, and it also now results in a much better flight. So this is, I'm going to say somewhat, it's arguably maybe a nicer way to go do science if we can break it apart into these chunks and analyze them more carefully, and then show that what we said works. So, yeah, if you're interested afterwards, message me. I'll send you that paper. It's a nice way of what I think about doing research too, where I want to understand these concepts well enough such that I can apply them to a bunch of different projects too, outside of even individual papers. So that's where like some qualitative metric to show that your model matches the intuition, show that. And the number 2 is usually show that it improves prior work. To show that, okay, your intuition was good, and now you have a better method than all the prior methods. This is like usually the 2 minimum steps I put in here. These days, you can have identify habitable planets as well, but it's sort of a version of this, let's not do some ablation. Show your this is really what we mean when we do an ablation. At the end, you might have combined like 16,000 different changes for your learning algorithm. Don't remove the individual conclusions that we put in. This is like clearly again. The pillars that we're talking about before is the problem. The problem identified by some intuition part that you can end up building on. Then you need some methods and some evidence that shows that it works. And at the end, this is we're pointing to the knowledge you get. No, it's specifically the thing that we change about the algorithm that allows you to perform that. So think about like those 4 pillars almost in every section that you're supporting well. However you want to end up going without doing these 3 different jumps. Okay. And then firework, maybe not related to work again. So kind of, I would often prefer to call this a discussion instead of an actual conclusion, depending on how you're going about things. But this is very often, yeah, remind people what the is. Not what the problem was, what the problem is. We're still in present tense, acting like we're solving the problem right now, the important problem of today. And better use something usually of this style. So you do want to, often in conclusion, you can talk about what the problem was, performs better. You can give some more details here for like how it performs better. Is like you should explain again what about your particular method of the experiments was showing that it was performing better than firework. Again, highlighting your novel contribution with the thing that helped that. And then also a pretty good paper these days will come into this last part and did some effort to kind of say, make some effort to say how, okay, other people can now take this work and use it. Hopefully in an easy way, you share your code. Everyone can reduce your research. It's a good start. These are usually the more important parts of getting to the discussion section. And future work limitations, maybe at this point. I guess we didn't get to talk about it much. You have the experiments here. Yeah, so we skipped a chunk. So like these are the experiments that you want to run. I guess in RL, it's often called environments. So tasks, whatever you're going to talk about and why these are good enough for, why these are good enough for evaluation. So you talked about like the experiments you want to run. And I'm sorry that these kind of like skip over papers. I think I can get rid of that. That's a little better. So you talked about like, these are the experimental questions you want to ask. Then you want to talk about the particular task you're going to run this on. There's probably a couple of different data sets for figuring out different types of planet estimations throughout the universe. So you'll want to pick like the best and hardest ones, because these are the current like state of the art. You can explain that the data is really sparse for each of those. So it happens to fit this method really well. And it's what all the prior work methods that you mentioned from before are using in their experiments. So this is where you split those parts up. You've got environment and tasks. Then, yeah, then you might have prior methods. You want to talk about these in different sections, and then you can talk about your results, findings, performance. So basically the guidelines follow the structure. It's obviously really hard to follow this. It's good to split it up. Let's talk about the data sets we're going to use, why they're important, why they're meaningful metrics for actual comparisons. Then you can talk about the prior methods, like why are you wasting any time covering these prior methods right now? Why are these the best ones to compare to in terms of understanding state of the art? And you should have already taken care of things in the related work section for any other method that you don't have to compare it to. You already explained why it's either not the state of the art anymore, or why it's really unrelated, or it can't be applied to the specific problem statement because it doesn't meet the assumptions. And then you finally get to talk about the results. This is so much work just to get to like the 2 paragraphs or 3 or 4 figures of finally getting to the paper, where you can say like, these are the actual results. You know, the method is a higher, if you're doing RL, you know, it's achieving higher reward, or if you're doing supervised learning, a lower loss, and it generalizes well to the other tasks for these reasons. And you can maybe have some information about how it learns a better representation on this data set than the other one, so it gets better results here than the next one. I think in terms of like scientists and stuff, students often have a much easier time with understanding how to explain the results and be picky about them. It's the other parts of like, all right, are you explaining to your reviewers about why the way you went about finding these results are good enough to validate your claims? And that's where you want to talk about like why these data sets, why these prior methods. And then you can talk about, okay, see, it does better on these data sets over all these prior methods. Aha, I have the best state of the art. Something like that. Makes sense? Any questions about experiment section? Okay, good. All right. So there was one, maybe we can even start with this one that I kind of wanted to explain for a minute. We'll do this kind of quickly. Maybe I'll start with this one. So the whole point is each one of these is supposed to end up becoming a paragraph. And we kind of want to get to the point where we start to write things that like are almost starting to look like a paragraph. So when we talked about like what are the limitations of current ML methods to count planets, we need to talk about the reasons why this is actually happening. So first sentence will probably be like ML models don't like sparse pixel information. Most data sets are collected and trained on dense information. Most data sets use, or I guess have, centered, what do you want to call it, object-centric pose. Hopefully that makes some sense, but that's the version, like the cat's face is always right in the center of the image. So in that case, all of our CNN learning models are basically fixated on this. We tune the number of filters we have based on this. So it's not very true. But you need to figure out basically how to start to support, like this thing now becomes a paragraph. You need to explain enough in the overall structure for why these things are difficult. This has led to possibly overfit unnatural images or viewpoints, at least. So this is explaining why actually this could be a whole issue. And then we've been collecting data. We've actually made it a bit too easy on our like, convolutional neural network models. So now, when you start to get to the point where now we're going to fill in the rest of the paper, we need to figure out what are each of the abrupt sentences that we're going to do for each bullet points. And don't want to start to add a few arguments. And now that I'm starting to talk about here, this community is like all the work fitting these data sets, and that it's hard to do these things. We need to provide some better solution here. We need a method that can, what does it need to do? It needs to understand sparse data in some better way than prior methods. And we need it to properly be able to sparsify some of the data and things that's going on. So usually you'll start to see some connections between the sentences in here. Now the next paragraph is one more that's you. Okay. So any other questions about this for now? We're gonna switch back to the slides for the last little bit. We'll go over a few more good tips and tricks. All right. I mean, if you've got questions, I'm connected on this. So if you leave a comment on this later about why doing it this way or the other way, let me know. Hopefully I'll have some time to respond to them.
Maybe you can hear me?
Okay. No, but it's still in the same tab. All right. So we made an outline for a little while. So there's at some point, depending on your own style, I like to call it making the move, where you actually want to switch from doing stuff in a Google document where it's easy to quickly prototype and just add bullet points. Now you need to actually start typing things in LaTeX, probably giving more formatting. So basically, when you start to get to the point in your writing, when you have to introduce things like math and notation, references, and figures, is around the time you want to move most of your text over to LaTeX. It's a little like more difficult to actually communicate and collaborate. You can kind of leave comments and overleaf, but to be honest, I hate those comments because when I like copy one of those and paste those, occasionally they disappear. So I still leave all of my comments in the actual text as just like, what is it, percent sign. Glenn thinks we should probably add far less text here and remove everything about all the theory in the paper because it doesn't make enough sense, or we need to save space. So you get to this point. So usually I try to stay in the Google document for a while. And actually recently I've been starting to use Notion instead of Google Documents because I can still comment on things, reference other people, and I can use math in there pretty well and copy and paste my LaTeX from the Notion document right into like overleaf and LaTeX. Just Google Documents is terrible for doing any type of math. So if you want to get to a theory, you must have already switched over to LaTeX at some point. Okay. So this is where, so after you've kind of moved stuff over to overleaf, it's really helpful to now you can start to include those comments on paragraphs. That's essentially this part in the overall outline. Now what used to be your more or less topic sentence or what you want to accomplish inside of this particular paragraph, start to just write out the sentences or at least proto sentences you're going to start to put together that'll help you make that statement in the paper. And then you can see how these just proto sentences for now, don't worry about what was mostly in workshop part 1 or 2 at this point. It's only after you've sketched out most of this stuff that you'd want to start worrying about actually making sentences. So that's what a proto sentence is. It's almost like half of the stuff I typed today, because not because they had spelling errors, but things that are just basically like, okay, explain what sparsity means. It doesn't really even give you much information, but you have to talk about that. And then you can say, okay, sparsity is going to be related to, being able to find nice representations that you can separate really easily. Most likely you can ignore a lot of the information. So you could even, if you want to talk about that way, like talk about it in coding length. So literally the amount of information that's embedded inside the image, can you get rid of a lot of it and just identify the only few bits of useful stuff? But anyway, that's more related to information theory. And then at some point at the end, when you've sketched out a lot of these, then you can start to convert these into sentences. Maybe move a few of the sentences around to make a more coherent paragraph. Then make your sentences more vivid and coherent and concrete so that like everyone in the room can really visualize and appreciate the like points you're trying to get across in order to convince the reader and reviewer about your work. Okay. And then review again for coherent structure. Remember, you're going to add all of these in. You might add a few more sentences. You don't want to end up kind of messing up the structure that you've written from before and maybe agreed on with some of your other co-authors, that this makes sense, and then let's just start filling that in. So it's good, like you make a pass, work on the outline first. Then maybe someone can go and add in these proto sentences for the introduction. Have someone go and look over these proto sentences. Do they make sense? Great. Then you just need to do like finish those, add references, and do some wordsmithing to make it sound much better. And then you can do the next section. Someone else will do the related work section, while some other person does the introduction for filling in those chunks, and then swap, and then just give people some feedback. And then one thing that I do find that's been really helpful too is we put this in here, and since we're all often very visual people, results, I might even like draft some figures. Like I would literally, I guess I have a small example from the slides, which I didn't really do too well. So you can convert these into LaTeX. This is just a link to the template I've made for LaTeX lately. So you can have some of the sections ready and then start to add a bit of the outline for what this figure will be. Like what should be here? What are you trying to show in this figure that aligns with your claims? Very often, it's actually a good point to add. Findings link these to the so 1 through 3. So you want to show that these findings are going to validate these things that we're talking about from before. So that's where I would start talking about in this section. Okay, we want to ask these 3 experimental questions. This figure is going to cover that question. And you'll start to be able to sketch out what it's supposed to look like before having any data about it at all. Just what we hope it'll look like, really. And then you can have a couple of different sketches for figures. This is just like a PNG image where I literally like just drew an X, so it wasn't just a white space in my paper. So I knew there was something there and it wasn't compiling it properly. But then you can start to just like go into like GIMP or Photoshop and just say, all right, some other people's methods, obviously not as good, and mine like almost perfect at the top. It's the ideal thing we want to see. And then everyone can visualize like the results and how it connects back to the introduction and the claims of the paper much better. And hopefully the evidence that we want to see, it's going to be in there as well. That one I find extremely helpful. You really want to help keep people on the same track and on the same page about what's going to happen in the paper. And then if it's somehow the evidence doesn't turn out that way or whatever, then we can figure out what to do when we're all like in like a very narrow bandwidth of confidence about what should be the content in the paper. Okay. Oh, that was great. Okay. So as I was mentioning from before, so these are all guidelines. They're meant to be able to help all of your process. There's always going to be some unique cases for special versions of papers, really annoying reviewers. There's always those cases. We still have kind of the responsibility to figure out, okay, putting the trust in all of you, we have to figure out how to write our papers for us. You are the people that are putting like literally all of the effort into getting these things to work. I mean, reviewers are okay, but often they're going to spend like 2 hours on whatever you did and judge it somewhat unfairly occasionally. So it's still like, you know your work better and how you should present it better. For your average reviewer, you might be getting some of the sparse reviewers that are like more outside of the distribution. Don't worry about them as much. And you know, the best thing for a reviewer is the best replacement for a reviewer is asking a few of your colleagues, like, can you understand this? If you have any other feedback, thanks. They're probably going to be a little nicer than a reviewer, but it's still the best approximation that we have. I already talked about being able to do this switch. And then, so part of the challenge for this is figuring out, so what happens when you run into something, you don't know how to explain it. Like in the method section, you might be working on a theory. To be honest, this is almost the entire point of doing it this way. So you can go through that outline and try to locate these things, these kind of like gaps in the conceptual plan for the overall project as quickly as possible. And then you can communicate them really well. So if you get to this point, you know, you can find these blocks really quickly, things that you have like a hard time explaining in terms of this outline. Leave some comments in here to help figure out what you're supposed to do. Maybe leave a comment for someone else saying, can you help me understand how to explain this chunk better? And if your outline is organized really nicely, they'll have a better idea of how to help you explain that section as well. Or it's actually literally part of the research. You did all this and you're stuck here on theorem sparse E10 is way too complicated. I have to go so deep into some kind of like sparse mathematics textbook or something like that. It's a challenge. So let's make a meeting just to talk about this one paragraph and work on it together. That happens plenty. And that's where you can also write out a few ideas. Maybe you've got like 3 ideas about how you can solve this particular thing. Now you can ask someone else, which one of these 3 ideas seems the strongest to you in terms of explaining it, showing like if it's the clearest or most novel way of doing it, or most version that like someone in the community would understand the best. So any questions about these? These are like bonuses that you get to take advantage of when you're writing things pretty structurally and coherently. Where we basically start with an outline, make another pass, add a little bit more detail to other sections, add a little bit more detail here and there. Okay. All right. So this is also helpful in 2 different ways. So it helps us get over a couple of the hurdles in terms of writing. So often this is like, we can start to partition our ideas apart from the actual words. And they're 2 different things. So we can kind of separate like our problem statement and mathematics and theory we want to do, apart from the, how do we explain this to other people? So if we give the outline, it's really just like an organized structure for all of my ideas and how they go together. And then we have to start adding details to each of those, like topics, sentences, paragraphs. This is how I'm going to explain to my average person who reads it to understand and appreciate each one of these concepts. So it's helping separate this complexity of these two different processes, like doing mathematics and theory, kind of a different part of your brain, certainly a different part of mine, it seems, and then figuring out how to write, come up with like better sentences, whether or not I think people understand these parts of the words or sentences, kind of a different chunk of my brain. So at least when I'm putting in content, I want to keep which one of these I use kind of separate for a bit, and then I can switch back and forth depending on what I am filling in at the time. Yeah, and this kind of like top-down process, the idea is really to keep things coherent all the time, so you could share a draft of what you've got with anyone at any time is the best goal. And yeah, I guess I almost finished some stuff there. So you can also change a coherent document much easier. But if you do want to put the related work section later on in the paper and make it really short because you end up not having much space or it makes sense. So if you've got a more coherent document, it's easier to see how to move things around and where you're going to have to repair a bit of the story because of what you moved. So this is also like just generally helpful for editing. Okay, and then I had the last few important points. So yeah, this helps avoid writer's block. Document is always in a state that you can share. It's much easier to refactor basically everything I just said. It's also good to help set some goals. So I thought this was supposed to come earlier in the talk, but basically like, what are you trying to get across? Either, let's start with like in this paper. So we can start with like, okay, so like some goals I had when I was starting to put together the workshop. All right, I want everyone to be able to write, to be understood, to make it easy for them to collaborate. That was my own goal, and I would keep that in my mind whenever I was making content for the workshop. And so then like part one, it's like, all right, some sentences are easier to understand with others. It's enough contributing to this goal of having to make it easier to be understood and be able to collaborate. And then the idea that like one paragraph should be one topic. Don't mix different topics together because it's much easier to explain. Writing is a skill like any other. Today, you know how to quickly make that others to understand easily and provide feedback. So, like in the comments at the top of your Google document, you know, what is the main takeaway you want your reader really, you know, to be able to get from the actual paper? Just so you keep those in mind. It's not good to not have a goal when you're writing. You should be able to check every once in a while, like, will this thing add to me achieving this goal, the main takeaway that I want the reader to have? And then there's a bunch of stuff on notation. There's two reasons I'm beginning to like mathematics a bit more lately than I used to. So it's good to do some theories, but literally you can now ground concepts into symbols in the paper. And this is kind of powerful tool when I want to say like, these are the parameters that I'm going to optimize. They're part of the network. Now you can just reuse that small symbol throughout the paper. So make good use of doing like notation and adding symbols and keywords to paper that you can reuse later. And one thing I also like to note here is like the paper is not like a weird translation of the code. You don't just like submit your code to NeurIPS or whatever machine learning conference and be like, see, there it is, you can run it yourself, no documentation. There's a bit of a balance here, but like sometimes I can appreciate the things that like DeepMind tends to share papers. They don't often share the code, but they try to do a pretty good effort of writing about how it works. Because, you know, like PyTorch is going to change probably in the next year. Who knows? We'll all be using JAX or something like that instead. So sometimes not actually the code is the best, longest term representation of even about how to share things. So this is like the conceptual part. Someone should understand what you did without having to look at your code. But if they want to continue on your research, they'll go find your code and build on it, go into the details. And the last part are just two things. One was web weaving. It's just basically add all those auto-ref statements so that people can kind of make little wormholes through your paper for yourself. So you can skip to like go into the experiment section or why you're using this particular prior work method back and forth, or which method you're using or explanation for the mathematics, things like that, so they can easily jump back to like, okay, here's the reasoning for why you're doing this particular thing. It's often helpful. And the last one is just going to be density. A lot of this is, okay, for example, one good rule of thumb is to make sure that your like introduction and related work section don't take more than 2 pages. This is going to take out of the space you get to talk about your method and your background section. So you want to make sure things aren't too dense with prior work and you have no time to talk about what you did. And it's also good to avoid pages that are essentially a giant wall of text. There's no images, there's no mathematics. It looks kind of daunting to know, like, okay, now I have to read what Glenn wrote, all this kind of convoluted stuff with a bunch of intuition. It's going to be limitlessly confusing. It's much easier if I add a few pictures, break it apart with some math, add some more symbols. This makes the paper flow much better and people can kind of parse through it easier as well. Okay, any other questions? Dan? Good for now? Okay, so now it's like almost a long weekend, so you can all go and write all of your outlines for your papers that you're hoping to submit next week and feel able to draft those and you can share them with people as well. So like keep some of these tools, maybe try your exercise as part of this one is to maybe just go write a little outline for whatever recent paper or project that you're working on right now. And then it'll help people understand why you're doing this project and how it connects broadly to the community. How to build on it as well. All right, so any last questions? All right, thank you very much, everybody. And do indeed have a good weekend. Yeah, I'll get around to sharing this information and editing a bit probably in a week or two for people who might have missed it, 1 or 2 of the workshops. Sorry? No, not to get like the content, just, yeah, I know I'll get back to that for now, but there was a few things I wanted to fix just about some of like the videos before I share them.